What's poppin', dogs? Mr. Allen here with a video on how to solve by factoring. For these 4 examples, we're going to be using what's called GCF, or greatest common factor. So for the first one here, I have 4x squared plus 8x equals 0. It's already equal to 0, so that's step number 1 if I'm going to solve by factoring. We're good there. Now I'm going to look for what's in common between these two terms. Well, 4 and 8 are both divisible by 4. So that's a common factor. But we also have x squared and we have x. I can take an x out of both of those. So my GCF here is going to be 4x. Now what I'm doing is I'm actually dividing out that 4x from each one of those terms. So if I divide out 4x from 4x squared, I'm left with x. And if I divide out 4x from 8x, 8 divided by 4 is 2. And I took out the entire x, so that's all we got there, equals 0. Now this is factored form. I can set my two factors, 4x equal to 0, and x plus 2 equal to 0. Now I'm going to solve for x. A lot of people want to subtract 4. That's not addition going on there. It's a multiplication. How do I undo that? Division. So I'm going to divide by 4, and I got x equals 0. 0 divided by 4 is 0. Don't panic and be like, what do I do? It's 0. Next one here, I'm going to subtract 2 on both sides of my equation, and I get negative 2. There's my two solutions for that quadratic equation right there. It's a degree of 2, should have 2 solutions. That's the fundamental theorem of algebra right there. It's pretty dope. Fundamental theorem of algebra. Okay, next one over here. Is that equal to 0? It is not. Okay, so I got to subtract that 5x on both sides. So I got 10x squared minus 5x equals 0. Right, the 10x squared and the negative 5x, those aren't like terms because one's x squared, one is x. Two separate terms. What's my GCF? Well, this guy's divisible by 5, as is this one. And we can also take an x out of both. They both have an x to give, if you will. If I divide by 5x, which we just said is our GCF, I'm left with 2x. And then I've got minus, well, I divided by 5, right? So that's gone. I divided by x, so that's gone. Do I need anything there? Yes. I need a placeholder of 1. All right? Equals 0. And it's negative there because that was negative right there. All right? But if I take out the entire thing there with my GCF, the entire 5x, I got to have a placeholder, whether it's positive 1 or negative 1, whatever that sign is, got to have it there. Okay? That's a common mistake when factoring with a GCF. It's like lose a term. Don't lose a term. It's got to be there. Okay. Now I can do the same thing. 5x equals 0. 2x minus 1 equals 0. So divide by 5 here, just like we did before, and I get x equals 0. Over here, I'm going to have to add 1 on both sides. So I got 2x equals 1. Divide by 2, almost out of space. I get x equals 1/2. So there's one solution. There's my other solution. Whee! Cool. There we go. 2 solutions. Degree of 2. Crazy. I love consistency in math. It's always very exciting, right? When you're like, hey, this kind of makes sense. All right. Next one down here. Oh, my goodness. A degree of 3, bro? What are you throwing at me? Okay. 7. That's really like a 1 right here. Nothing in common there, right? But they do have an x squared I can take out. So I get x squared, and then I'll be left with, well, if I took out an x squared from here, I've got 7 still, and an x left over. I'm taking out the entire x squared. Do I need anything here? Yes. We just talked about that, right? So this time I'm going to have a plus 1. That equals 0. Now I can set my two factors equal to 0. So I get x squared equals 0, and I get 7x plus 1 equals 0. If I square root on both sides here, that's the easiest way to solve that one, right? I get x equals plus or minus 0. Well, no, I just have x equals 0. But it is a multiplicity of 2, so technically that solution does appear twice, okay? If you were graphing these things, you'd see it like bounce off the graph. We're not doing that here. All right, this one, I'm going to subtract 1. So I got 7x equals negative 1. Divide by 7. So I got x equals, I'll just jot it over here, x equals negative 1/7. So those are my two unique solutions, but it's still technically 3 because this one has a multiplicity of 2, and that one. When you get into polynomials, you'll see a little more of like a multiplicity of 2. I'm not going to list it here. Those are my two, solutions that would work here, right? But 0 happens twice. Whatever. We'll move on from that. Okay. Last one here. I'm going to go with the yellow marker, which kind of looks like this one, but whatever. It's going to be 4 different colors, okay? What do they have in common? Well, I can divide. It's already equal to 0, right? That's good. That's a win. I can divide both of these by 3 and take out an x. So I got 3x, and then I'm going to have 3x minus 5 equals 0. 9x squared divided by 3x is 3x. Negative 15x divided by 3x is negative 5. Cool. Now I can set my two factors, right, because they're just two factors, equal to 0. 3x equals 0. 3x minus 5 equals 0. This one here, easy peasy, divide by 3. Can't divide by 0. X equals 0. Yay. And then this one over here, I'm going to add 5. I get 3x equals 5. Divide by 3. And I get x equals, I'll put it over by this guy, 5/3. Hopefully we didn't run out of space. I know it's getting a little low on my board there. There we go, guys. 4 dope examples in that one. That's awesome. Going to move on to some other factoring. It's going to be dope. See you dogs later.